Good morning. My name is Usman Shakil, and I'm the worldwide tech lead for media and entertainment at AWS. And along with me here today is Tom Nightingale, who is a solution architect with the AWS Solution Builder team. So today here we're going to be talking about building serverless video workflows. So just a quick show of hands, how many of you are here to listen about or hear about serverless? All right. What about video? Cool, awesome. So I don't know if you guys know, but we had our media and entertainment track yesterday, and we had a whole bunch of sessions yesterday talking about different things, similar things as well. And we launched AWS Elemental Media Services yesterday as well. How many of you are aware of that? Cool, that's good. And we're going to be talking about a bit about that here as well. So kind of you heard about the announcement. I don't know if you tried out some of those services already or not, but we're going to kind of try to show you a realistic example of one of those media services here. How do you take it and build the entire workflow through it? So this whole project, serverless video workflows, started a while back. So a lot of our customers, whenever we go out in the field, we'll talk to our customers. We'll say, hey, we have all these different building block services, how you can use EC2, our compute service, our storage service to kind of say store your content, to encode or transcode your content or process your content using EC2. With your own sort of say bring your own encoder kind of a thing, if you will, or even use the Elastic Transcoder service or Elemental Cloud, etc. So, but basically being these building blocks that you have to kind of put together in order to build a complete end-to-end workflow for video streaming. And when we talk about video streaming, obviously we're talking about both live as well as the file-based streaming, and we'll talk a bit about both here, right? But what our customers were really looking for was, hey, can you give me some example of this whole thing working together? Well, one thing is, what is streaming? Well, I can put my content, which is already pre-packaged or pre-processed in an S3 bucket, and I can put it behind a CDN like a CloudFront, and I could just simply stream my content. Well, that's great. I can, for the live, I can be running a streaming server on EC2, pick a compute instance, and then put it behind a CDN, and basically there you go. There's your live stream. But if you look at it realistically, there's a whole lot more that goes into it. Things like you have to transcode, encode, package. You have to apply DRM, watermarking, even do QC on the content when you receive it. So there is a bunch of different tasks that go into this workflow. And that's where having something which is simplistic and kind of gives you as an example starting point that you can start, and then you can build or customize, kind of treat it as a framework and customize your workflow could be pretty handy. So here's a quick agenda. We're going to start with a quick introduction. A bit of it I already did, voice of the customer. We're going to talk about the relevant AWS services, and then we're going to talk about how we work backwards from the voice of the customers, what customers were looking for, what we ended up building, and when I say building, it is actually a solution which is available on the AWS Answers page, and Tom here will give a demo of the solution. We'll talk about the evolution of the solution, where we started with the MVP, what is available today, the version 2 of the solution, and our future plans with that, with the solution. So quickly on the introduction, and I'll kind of breeze through these slides because I would, given the crowd here, I would think that most of you are already aware of this, and that's why you're here. So one of the key trends we're seeing in the media space is this massive explosion of content and devices. Everyone is creating video out there, right? With the kind of say the newcomers like Amazon and Netflix and others, creating their original content. There is just so much content out there, and people want to be able to watch content anytime at any device, basically on their own schedule. Nobody is sitting there waiting for a particular time of the day to hit to sort of go and watch their favorite content that they want to. On the right-hand side on the screen, you see this chart which shows you the amount of dollars in billions spent, across from 2013 all the way to 2015 across these different companies. And as you see, the amount of dollars spent is constantly increasing, with respect to these original content from the newcomers that are coming into this space. And the devices everywhere. We know there is this streaming that people want to be able to, as I said before, be able to watch their content anytime on any devices. And that kind of brings this whole thing around OTT services that more than 49 million homes accessed at least one OTT service, right? So with devices like Fire TV and others out there, smart TV and all of that, you see that you can watch your content basically at your own schedule. But when we talk about these OTT services, as I said before in the very beginning, it's not just about this streaming that I have my content sitting down there and I could just simply deliver it, right? I have to process it, I have to QC it, I have to package it. In many cases, maybe do ad insertions, DRM, basically depending on what model you have with respect to your business. The other trend that we are seeing is, the companies want to be direct to the consumer, or also more relevant to the consumer, right? So in the old days of broadcast, it was hard to kind of say do personalized advertisement or kind of to the point content for specific audience, whereas streaming on specific devices really allows the content owner to do that. Again, what you see here, these two charts, it talks about the pay TV net changes by provider, right? So like between telcos, the cable providers, the satellite, and streaming TV. And as you can see, the trend, the streaming TV is kind of gaining, whereas all the other models are getting down. And same goes from the ad revenue perspective as well. As you see the red line over there on the chart, that really talks about the streaming via internet, right? The ad revenue that is spent with respect to the different channels. And we see all these news all over the place, how all these major media and entertainment companies are going straight to the consumer. But that said, OTT is very complex. This is actually somewhat of a simplified version of a realistic workflow based on the customer requirements that we got, right? That basically in the middle you have these infrastructure services, like you have to store your content, you have to ingest your content, deliver your content via the network, you have to process your content over the compute, and you have to store metadata or state with respect to that workflow in the databases. But on top of that, there is a whole lot of complex business logic that goes into play, that includes all these different things. I'm not going to try to go through it, but for those of you who have tried to do something similar, kind of get the complexity of this. But what we see out of this is an opportunity to help our customers get rid of this undifferentiated heavy lifting. Now, at the basis of it, it is actually a pretty niche business, right? So let's say it's specific to video, it's specific to streaming, but it's generic enough that we think that it could be very easily managed as sort of say services from AWS side, and it's not something that our consumers or our customers should be spending a whole lot of time going out and build. Rather, spend time in terms of how you can improve the quality of the content when you go to your consumer, right? How you can make sure you give them better personalization or recommendations specific to the content. So kind of taking it at a higher level, right? So taking the complex OTT workflow and kind of defining it into a higher level, basically you have the business plane, which is composed of these sort of say 5 steps, where you're first ingesting or acquiring the content. That ingest and acquisition of the content workflow itself has multiple different steps, from say quality check to metadata extraction and all of a bunch of different things. Then you're storing or managing the content, where basically the content lives somewhere, say in a content lake, for example, and then you have an asset management associated with it. The next step is processing the content, where you're taking an input or the mezzanine asset, or whatever format that you received it, and you're normalizing that asset. You are transcoding it, encoding it, and a bunch of different tasks there. And then you are making it ready for delivery, basically staging it for delivery within your origin store, and then you're delivering it to your consumers. But it does not end there, right? So once the consumers receive it, then you want to analyze how your consumers are watching that particular piece of content, and then taking that data, that logs, back from your consumers watching the content back into the workflow to improve the workflow, and also to do personalization for that workflow. Now, a lot of you have also heard about the whole AI and machine learning stuff in there. So all of that becomes very relevant in it, because if you have your content close to all these different services that are available to you from, say AI or ML perspective, things like Amazon Rekognition, et cetera, where you can then start extracting additional rich metadata within that content that gives you additional monetization capabilities within this workflow. So the idea being that you want to store your content once, and you want to deliver it anywhere, and you want to do anything that you want with it. Because in this entire workflow, the hardest bit is moving that content around, right? Because that's where the speed of light is the problematic thing, right? Because you have the massive explosion with respect to the size of the content files are growing big, and you don't want to be in the business of, say, moving content back and forth. Rather, you ingest content at a place which is highly flexible, scalable, cost-effective, and not just that, but rather gives you access to a lot of additional value-added services that you want to add to your content. Hence the whole analogy here, store once, deliver anywhere. So the AWS stack for media streaming workflow, again, taking the simplified version from ingest to store, process, and deliver, there's a lot of different services that you will see that are at play in this entire glass-to-glass workflow, which is basically from camera to the device, right? So as you can see on the source side, there are even things like Amazon Snowball that you can use for ingesting large-scale content at secure and at scale. You can look at network capabilities like Direct Connect, S3 transfer acceleration, storage gateway, et cetera, that allow you to really ingest file-based content at scale. AWS Elemental also offers you on-premises appliances that allow you to enable live streaming workflows directly integrated into the cloud-based services that are offered, like Elemental Media Store or Elemental Live, et cetera. On the storage side, you'll see S3, Amazon S3, Glacier for your kind of think of it as a content lake where your content rests, or resting place of your content. You have EBS or EFS, which is more like file-based for processing type of workflows. We launched AWS Elemental Media Store that we can talk about a bit more, but basically the idea here is for a highly scalable, fully managed, low latency origin store for live content. Right? That's AWS Elemental Media Store. On the processing side, you'll see EC2, VPC, Lambda, all these things, these constructs, if you will, that we will talk about. And then in order to store your state, you have relational databases like RDS as a service, DynamoDB, et cetera, and then machine learning. We also launched 3 additional services for media processing, AWS Elemental Media Convert, that we'll talk about in much more detail here in a little bit, AWS Elemental Media Live for live streaming workflows, AWS Elemental Media Package for packaging of the content. And then on the delivery side, in addition to the CDN, Amazon CloudFront that we have, there is AWS WAF for security, application firewall, if you will, Route 53, Lambda at the edge, that allows you to do a lot of these things from security to real-time log collection from the player, for example, or from the CDN side, and then pushing it back. And we also launched AWS Elemental Media Tailor that allows you to do manifest manipulation on the fly to be able to offer server-side ad insertions, for personalized server-side ads. So as you can see, this entire end-to-end workflow, and we are talking about, by the way, just the delivery aspect of it, right? We're not even talking about the content production aspect. There is a whole lot more that is there to offer from AWS side on the content production. But on content delivery side of it, there is a whole set of services that we will use as building blocks to build these sort of say high-level up the stack solutions, such as the one we're going to talk about. And also on top of that, there is the AWS partner solutions. We work very closely with the AWS partner solutions, whether that is DRM or watermarking or asset management systems, et cetera, to integrate these services very nicely, with the sort of say common household names that you guys are used to working with. So the ones that are launched are specifically these AWS Elemental Media Services, just to kind of point the attention there. What I'm going to do here is I'm going to talk about very quickly about Media Convert, what AWS Elemental Media Convert does, because it's very relevant in this workflow that we are going to be talking about. So first of all, it is available as a service in the AWS console. So you can just simply go to the AWS console and you can launch a Media Convert job. You have access to professional grade video features and quality. So very similar to what you would have access to in a professional grade encoding appliance. Now you have it in the cloud. There is no software or hardware infrastructure to manage. It's fully managed service. So it's not like you launch an instance and then you launch a software on top of it, you deploy some code. It's nothing like that. Basically, you have a video a transcoding or encoding job that you can push into Media Convert. It automatically scales in response to variations in the incoming video volumes. And as we'll talk about the whole tech kind of say architecture there. And then it has the ability to manage capacity and control order in which jobs are processed, right? So like first in, first out kind of a model. And then it gives you a fully rich API interface to integrate with Lambda serverless functions in a complex workflow. Now, this last bullet is exactly what we're going to be showcasing today, how you take Media Convert and then you put it in a pretty complex end-to-end workflow. So there are a few constructs with respect to using AWS Elemental Media Convert. First of all, there is a job, which is the primary unit of work. So you can specify an input and an output. So basically, there's an input file, which could be a mezzanine asset, and there is an output file, which is a fully packaged, ready to deliver asset, or sort of say containerized asset. Then you have an output preset, which is a sort of say configuration settings to create a single output. So let's say if you want to create an MP4 output, or if you want to create an HLS output, etc., you specify that output preset. You can talk about. You can also put the specifications with respect to the screen resolution, etc., within that. And then there is a job template, which is a collection of commonly used job settings. So there is a bunch of commonly used job settings that are pre-created, canned, that are ready for you to use. And then there is queues, right? So basically, you will submit a job that will have an input file, an input asset associated with it, and a preset, which is the configuration of what you want to do to that asset, and that goes in a queue. And then all these jobs are sequentially processed throughout the queue. So, again, taking this whole business plane one more time, as you can see with these new Elemental Media Services, they line very nicely to the different sort of say steps within this business process. So working backwards, so this was a bit of an introduction about AWS services, what we're going to be using. And now let's talk about working backwards from the voice of the customer. So I want to introduce AWS Answers. How many people around here actually know about AWS Answers or have used a solution from AWS Answers before? Yeah, good. Maybe a few. So, as I talked about, the AWS services really are sort of say building blocks, right? As I gave the kind of say that Lego analogy, right? You can think of AWS Answers as a Lego kit, for lack of a better term, right? Basically what it does is it takes these building block services that are out there and kind of gives you this nice looking Lego kit, which you can simply deploy and gives you a solution. So as an example, we have a few media specific solutions that we've done, one of them being live streaming solution, right? So this is specifically what one of the AWS Answers solutions delivers. So basically, it is a CloudFormation template, and Tom will demo it in a little bit, that once you launch it, will actually go and launch this entire environment for you inside of your AWS account. So what this is doing is specifically taking creating, using the CloudFormation to create an AWS Elemental Cloud setup for AWS Elemental Live, as well as AWS Elemental Delta, and it spits out an endpoint for that AWS Elemental Cloud that you can use to start pointing your source video stream into, or your live stream into. Once that stream comes in and it's processed by Live and Delta, packaged by Delta, it actually spits out the underlying output that you have requested through your AWS Elemental Cloud settings. And then there is a whole Nginx cache cluster in front of it to kind of give you that HA and scalability in an auto-scale group. And then through the elastic load balancing, it goes out the cloud front into the devices. So the idea being that as a customer, you are able to go into AWS Answers and be able to launch this sort of say solution very, very quickly and very easily. And you have a live streaming solution, which is fully HA as well as scalable, and also gives you all the CloudWatch logs, et cetera, with respect to it. And more importantly, flexible, that is configurable based on your needs. So we kind of, if you look at the different AWS Elemental services we launched, right, from this particular architecture to this, it simplifies it even further, right? So in this particular case, you had to think about, hey, I have to launch 2 different live nodes in order to do an HA, or the template was doing that for you. Whereas now, with Elemental Media Live, you just simply create a channel within Live, and it is fully HA. So the HA is kind of say built into that. Similarly, the Delta or the Elemental Media package will work the same way. Media Tailor is fully managed as well. So if you want to do ad insertions, etc. So this kind of makes the workflow very, very easy. The second solution we're going to talk about is file-based streaming solution. We're going to kind of focus on that because that is where the whole complexity around the supply chain comes into play, because you're ingesting all these incoming files, and then you're running the supply chain process, and then finally the delivery of it, right? So basically the way we look at it is strategic service development, right? So you can start with the lift and shift, which is you can build infrastructure, move the platform, automate. Then the second step is optimization of it, where you now take this monolithic application, you transition these services, integrate monitoring to it, as well as abstraction of data. But finally, the end product of this is actual transformation. So while you could do a lift and shift very, very quickly, the actual or the most important thing is the transformation. How can we make sure that it is actually using the best practices that we provide our customers as a solution? How can we say that this solution is actually the well-architected solution for our customers to be able to use in this particular context, right? But what you will see is that for every single progressive step, we get better and better with respect to that solution, and as a result, the solution that you see is best suitable for your needs. So as an example, right, so the first step, you look at higher utilization, faster provisioning speed. How do we do that? By appropriately using the EC2 instances, for example, the right spec and whatever goes in there, putting in disaster recovery, improved uptime, etc. Similarly, trading CapEx for OpEx, more scale, it's elastic resources, all the different benefits that the cloud provides you. But there is still limitations, right? You're still in the business of, say, managing these compute instances or servers, if you will, right? You still have to think about capacity, utilization, size, availability, being able to run intermittent jobs, etc. So for that, there is the whole concept of serverless. That's where it comes into play. Because what you're going to see is in these file-based workflows, right? It's all, what is it? It's a batch job, a complete batch job, end-to-end workflow where different tasks could be run as individual batch jobs. And that's where Lambda or serverless is very appropriate with respect to it. Why? Because it's very low touch. It's very high developer productivity, because you can simply write a few lines of code in order to do a complex function that could be running, say, an encode, a transcode, a package, etc., or a job with respect to that video asset, right? And basically, again, you're not provisioning any servers, or you're not managing any servers. You're scaling with the usage. You don't have to worry about, hey, I have an auto scale group that I am managing, and now I'm paying, for EC2 instances, etc. You're never paying for idle, basically, and the availability and fault tolerance is built in, because you're looking at a higher level, higher level spec there, instead of kind of going deeper down with respect to baseline services. So with respect to serverless, there are multiple different patterns out there that you can use serverless. And this talk specifically is not about kind of educating you about serverless. I'm sure, if you're interested in serverless, you've kind of heard about many of these patterns or tried these patterns before. But just a very quick refresher, obviously you can coordinate by method call, meaning you have a function that needs to be performed on a particular asset. You can call a function, that's a serverless function, goes, does its thing, and then you're done. The other piece is basically you are coordinating by daisy chain method or function chaining method, right? So basically an asset came in, first step, I'm going to run QC. The next step after QC, I'm going to process. After process, I'm going to package. After package, I'm going to put it in the origin store, and then I'm going to deliver. So each one of these functions could be say Lambda or serverless functions that are, say, daisy chained together. Then you can coordinate by database, basically where after every single process, you are pushing the state into the database, and then the next process wakes up, it picks it up, and then does its thing, and so on and so forth. Or you can coordinate by queues. I talked about media convert a little bit in depth, but basically the idea being that's where you have the entire queue, and that is a fully managed process that works within its own queue, but kind of very similar idea there. So the way the AWS step functions work, and again, a very high level kind of idea here, you define a JSON, right? And then you are able to visualize it in console. So the idea being that complex workflow that I started with, right? That whole business process, you can actually view it inside the console. And then you can drill into each one of these tasks to kind of look at what does the underlying code look like, right? Can I customize it? Can I change it, etc. You can further go on and monitor the executions. What is the state of each one of these processes? Where is my process either failed, if I've built in some error logic in there, etc. But that's the kind of idea. You can go in the console and try out if you haven't yet. So video on demand workflows on AWS. This is specifically the architecture that was built in that AWS solution for the file-based workflow. So just to quickly walk through it, you have a source video that comes into S3. S3 opens or turns in a notification that then triggers a workflow, which is the ingest step function. Now that ingest step function is going to have a bunch of things that I'll talk about. Then once that ingest step function is done, it's going to trigger the process step function. So remember the pattern I talked about, daisy chaining, so one function calling another function, right? So that's where the ingest function is calling the process function. The process function does its thing, and there's a bunch of steps within that. That then, through Lambda, calls AWS Elemental Media Convert. That does its thing. It actually generates an MP4 as well as an HLS output that then publishes or calls the publish step function via a notification from the Elemental Media Convert. And then the publish step function makes these two outputs available in specific S3 locations. And then for the HLS, you're going out and delivering it through Amazon CloudFront. So throughout this process, what you're going to see is it's all done through Lambda, a bunch of different Lambda functions, and the state is saved over DynamoDB, and the notifications sent out via Amazon SNS. So the idea being, when you go in there and you deploy this template, this environment is set up in your AWS account. You will have a bucket where you can start putting in files, and you can run through this workflow very quickly. So kind of quickly, again, walking through some of these steps functions. So the ingest step function, what it does is it starts, when it starts, basically it starts by a notification that is triggered by the S3 bucket. So S3 bucket will have notifications enabled. Anytime a file lands in S3, it will trigger this workflow. Start, validate source, run media info to make sure that this is a valid media file, and then kind of say compare it with the metadata file. Then create an entry or put the state in DynamoDB, send out a notification to the process function. The process function comes in, it profiles the content or media, does the encoding bit, then puts the step function or actually state into DynamoDB, and then ends the function. And then you have the publish function, again, that validates the outputs from the process function, right? That the outputs that were generated are correct, puts the state in DynamoDB, and then if you want to archive, say, the MP4 output or the original mezzanine asset, then it can actually push it into Glacier, and then publish it, that is, make it available, ready for your OTT application for streaming, right? So then you can actually publish that content within your app, that it's now available for your users to be able to go and view. Now, one of the other key features there is the Amazon CloudFront. So obviously, you're going to need a highly scalable, a CDN in order to deliver that. Now, as I said before, all of these services work hand in hand as different Lego blocks, right? You can use Amazon CloudFront as an option within your streaming workflow. CloudFront today is a major CDN. It has over 100 points of presence, 88 CloudFront edge locations, 11 regional edge caches across 50 cities and 23 different countries. You can optimize cache. There's a lot of different options there in order to optimize it. You can whitelist query strings and cookies, for example, as well as there is reserved capacity pricing. So if you have, say, a large-scale application that you're deploying or large event that you want to stream using CloudFront, then you can use reserved pricing through that. I'll quickly go through this. There are some cool features within CloudFront, but I want to make sure that we have enough time for the demo. But this here specifically talks about CloudFront access logs and how you can use it to look at how your users are actually accessing your content or viewing the streams and report back on that. So with that, I'll pass it over to Tom to talk about how we built the solution, demo the solution, and then how this solution evolved based on the voice of the customer.
Hi, everybody. So in this next section, I'm actually going to dive into the solution that we built. I'm going to look at version 1, which was our look at the customer feedback that we got, and then look at version 2, which is the current published version of the solution. So for MVP, we just wanted to build something simple, get it out there for our customers. We looked at just building a very simple process where we had a single input with multiple outputs. We built 7 encoding profiles or presets for Elastic Transcoder for MP4 and HLS. And those were based on the Apple Tech Notes from 2016, which you can see up here. And these were their recommendations for HLS streaming. As part of the process, we wanted to demonstrate how to make an encoding decision. We wanted to deliver that HLS content through CloudFront. And then we have SNS for notifications, and we wanted to capture all the information coming out of the workflow into DynamoDB. So this was the original architecture, very similar to the current version that we had. We've got our S3 for source and destination. We're using step functions as that orchestration layer for our ingest process and our publishing process. And then in the original version, we were using Elastic Transcoder for that encoding. So what I'll do now is I'm going to switch over and actually take a look at that version. As Usman mentioned earlier, this is AWS Answers. This is where all our solutions are published. If you look under the media and entertainment section, you'll find our 3 published solutions that we have to date. And then here you'll find the video on demand solution. There's a technical brief about the solution, and then there is an implementation guide with every solution that we publish. And if we go to the deploy section here, you'll get step-by-step instructions on how to deploy it, and a link to a CloudFormation template that will actually launch that infrastructure in your account within a couple of minutes. So I've actually deployed that already into my account, and I'm just going to walk through to show you how the workflow works. So here I have my source bucket, and I have uploaded a video up into this source bucket. Does everybody know the Big Bunny video? Yeah, is everyone sick of watching the Big Bunny video? Yeah, we won't watch it, I promise. So here, yeah, I've uploaded a video. If we take a look at the properties on this S3 bucket, we have a series of notifications set up. Here you see that these are set up for different file extensions, video file extensions. And if we look at that event, what we're doing is, we are triggering a Lambda function on a object create. So every time a file is uploaded to this bucket, it's going to trigger this Lambda function, which is our ingest execute. This is just a simple little Lambda function. What it does is it takes the event data, it gets the bucket and the key from that source event. It generates a unique identifier, which is a GUID that we're going to use to track our assets through the workflow. And then it triggers our ingest step functions. So if we take a look at the ingest process, we'll see, if we look at the inputs, there's our GUID, there's our unique identifier. We're going to use that as the primary key in our DynamoDB table. We have the source file, and we have the bucket. First step, very simply, just writes out that information to our Dynamo table, so we've got our initial entry. The next step is we're running MediaInfo, which is an open source software that will allow you to extract metadata from your source files. And we're taking that information, we're writing that out to DynamoDB. Next step is the profiler. This was our encoding decision. Just for the MVP, it was a very, very simple decision process. What we did is we took that metadata that we got from the previous step, and we're getting the height of the video, and then we're using that height to set a encoding profile for our source file. So in this case, it was a 1080p video. So that variable then tells our 2 encoding steps to use the 1080 profile in Elastic Transcoder. So for MP4, we're creating just a single 1080p video. For HLS, we're creating 1080 right down through those 7 presets that we created. And then the very last step is just a quick update. So we're setting the status in Dynamo to say that we've ingested the file, and we're sending out an SNS notification to the administrator to say the file has been successfully ingested. So Elastic Transcoder, does its thing. We get 2 outputs from that process, and Elastic Transcoder is configured to send SNS notifications out on a completion of a job. And similar to our S3 event, we have a simple Lambda function that's hooked up to that notification and actually triggers the publishing process. For the publishing steps in MVP, because we're using Elastic Transcoder and we wanted our content to be in 2 separate buckets, so MP4 in one and HLS in another, we actually had to submit 2 separate jobs to 2 different pipelines. So for that reason, the publishing process actually runs twice, because we're getting 2 notifications out of the system. So the very first step for our publishing process gets that output from SNS, figures out whether it's the MP4 or the HLS contents that's completed, and then passes that information down to the next step, where we have a publishing choice. Now there's no Lambda behind this particular step. It's purely just state machine logic. So in step functions, I can set up this choice state where I am looking at this variable pre-step, and if their string value is MP4 output, we're going to go down the MP4 route. If it's HLS, we're going to go down the HLS route. So this is a way that we can use step functions to make a choice. And then for the last piece of the process, if it was an MP4 file, we're reusing that media info Lambda function, generating some metadata about our MP4 file, and then creating a metadata file to sit next to that MP4 output. For HLS, very simply, we're just taking the outputs from ETS and generating that CloudFront URL for the HLS content. Once both lots of content have been processed, we're then setting the status in our Dynamo table to complete and sending out an SNS notification with the details of the outputs from the process. If I take you to the Dynamo table, you can then see that we have all of that information that we got through the process we've stored in Dynamo. So we have our link to the CloudFront distribution. We've got our metadata for our media files. We've got our details on the buckets and details on the outputted files and the time that it took to complete. So that was MVP. That was the first version. Very, very simple sort of workflow, but it demonstrates how we could use these services to create this process. We published this on AWS Answers. We got it out and started talking to our customers about to get some feedback. There are lots of positives. People saw the benefits of using step functions as that orchestration layer across the workflow, how you could leverage Lambda for those individual steps. There's a couple of things that came up from that feedback, and that's what I'm going to look at in this next section. So for version 2, these were the sort of 3 main areas that we focused on. First piece I want to talk about is decoupling the workflow. And what I mean by that is, if we look a little more detail on that media info step, one of the customers that we spoke to loved the solution. It was exactly the type of thing they were looking for, but they already had their own database service that they were using. So the question was, how do I take your code and make this fit with my own database? And that's when I realized we'd kind of made the wrong decision in the early stages. If you look at this code here, what we're doing is we're creating a signed URL for the object in S3. We're running media info on it, so we're not having to download the file. We can just run it directly from S3, getting that metadata, and then calling Dynamo and writing out that information to our Dynamo table. Similarly with the encoding steps, we're creating that Elastic Transcoder job, getting the job ID back, and then writing out that information to Dynamo. This is when I realized that if this customer wanted to take this solution and build on top of it, they'd actually have to rewrite every single one of those Lambda functions to use a different database service. And that wasn't what we were looking for. We wanted something that was really decoupled. We want it to be easily customized so that you can move these steps around, you can add stuff, take away stuff, and that isn't quite what we've got here with this first version. So what we did is we took a look at relook at step functions. The first thing we did is we actually split out that first step function into two. So now we have an ingest process and a processing workflow. And we changed the way that the steps are working. So here is the updated media info step. And rather than writing out to Dynamo, we're running media info on our file. And then we're taking that output and just adding it to the event data that we got at the start of the process. And so each step performs its task and then just adds to that event data. And then when it's applicable and when we need to, we can call on a separate Dynamo function to take that information and write it into our Dynamo table. Again, with the processing step functions, and this is the updated version using media convert. Same thing, creating an encoding job, getting back the data, for, the job ID, adding it to the event data, and then calling our Dynamo function to write that information back into our database. So now, for that customer who wants to use their own database service, all they actually have to do is replace that one Lambda function to write information out to their own database service, and they can use the rest of the workflow as it is. And the other nice piece about that is that the Dynamo call here is actually the same Lambda function that we had in our ingest step functions. So now we have reusable code. We have a Lambda function that we can drop into our step functions when and if we need it. And we've got a much more decoupled microservice kind of driven workflow. So that was the first piece. Second piece was better error handling was one of the some of the feedback we got from customers. So if we take a closer look at version 1, set up some very, very basic error handling. Elastic transcoder, in the same way it sent SNS notifications for completed jobs, it will send out SNS notifications if there are any errors. So we're capturing that in SNS and sending it out to the administrator. With step functions, you can set up CloudWatch alarms that will monitor those step functions, and if there are any errors, that again can trigger an SNS notification, and we're sending out a notice to say that something failed. And then on the right there, you'll see this is an example of the CloudWatch alarm. So the two things that came out of this were that firstly, that error message is not particularly detailed. It doesn't tell me what asset failed. It doesn't tell me in which step it failed. And we wanted to show something a little more detailed. And more importantly, we're not capturing this in our Dynamo table. So for the workflow, we're capturing state. So we have a state of ingest, encoding, completed, but we wanted to get that if and when there are errors, we wanted to get that into Dynamo as well. So version 2, what we did was we actually added a little error handler to all of the Lambda functions that sit underneath step functions. And what that module will do is, if the Lambda step fails for any reason, it will take the event data the input that it got, it'll take the error message and the function name and actually fire that out to our errors SNS notification. Elastic transcoder, the errors coming out of there were fairly detailed, so that was left as is. For the new Elemental Media Convert service, you can monitor what's going on there using Amazon CloudWatch events. So we set up a rule that would look for those errors and then again fire those into SNS. And then from there, we just have a simple error handler that will Lambda function that gets those notifications, passes through that information, figures out the unique identifier, the GUID that we had, puts that information into our Dynamo table, so we've captured that error state, and then sends out an SNS notification to the end user in the form of an email so that they're getting those details there. So that was version 2, much more detailed error handling. The next piece, the third piece I want to look at, is introducing Media Convert, the new service, and also looking at some of the encoding options and a little more complexity to the workflow by introducing source metadata. So when you go to the published version now that we have, there are two CloudFormation templates. There's one that will deploy a video-only version of the solution, and then one that will deliver a version that uses metadata to drive the workflow. If we look on the right there, those are the parameters for the CloudFormation template. So we've added in some extra options around the encoding. You've now got options around setting your MP4, HLS, and dash output. You've got thumbnails. You've got the ability to add in watermarks to the encoding process. And we've added a step, there's another piece of feedback, which was the ability to use Glacier to archive that source content once the workflow is finished. This version is triggered in the same way as the MVP, so the source video is dropped into your S3 bucket, and that kicks off the workflow. So much more options around encoding there. But those choices that you're making with the parameters of the CloudFormation template, those are hard-coded to the workflow. So every video that you drop into this process, it's going to end up with the same output. We wanted to take it a step further and just add in a little more flexibility. So there's a second CloudFormation template you can launch, and that will add in the option to drive the workflow using metadata. And we built in support for JSON and for XML. And again, these are sort of very simple metadata files, but if you were talking about large broadcasting workflows, you could imagine that could be ADI compliant XML, and have a lot more information in it. But just to demonstrate how to do that, we added in this as an option. And as you can see, if you look at the XML and the JSON examples there, very much similar to the CloudFormation parameters we had earlier. And what that does is we've just added in that extra validate metadata step to our ingest process to ingest those settings so that we can tell Media Convert what outputs that we want. So still fairly simple, but just demonstrates how you can add more flexible encoding options into the workflow. The other piece we had was Media Convert. So what was really nice about this new service is that there's no setup required. You can make an API call out to the service, and you can get back the custom endpoint for your account. So there is an API endpoint for each account and one per region. So you can actually make a call, get that API endpoint, and then we can define all of our inputs and outputs as a single JSON object as part of the encoding request. So this is an example of the code that we're using, and as you can see here, we're able to add in some user metadata, so we can actually add in our unique identifier in there, so we can identify the job once it's completed, and then we can build out this JSON object and add in HLS content with a specific output bucket, dash with a specific output location, and again MP4. So really, really flexible interface. So let's take a look at that new version, starting with S3. Here are our source and destination buckets. We have the logs bucket as well for CloudFront. If I go into the source bucket, I now have a watermark directory, so I can drop watermark files in there if I want to use those. I have my Big Bunny video. Don't worry, we won't watch it. And I have an XML file with those encoding settings in there. If I look at the properties and go back to our events, so again, we're triggering the same Lambda function, but this time we're looking for anything with a JSON or XML extension. And then if we go over and look at our lifecycle policies, we've actually added in a lifecycle policy here that will anything tagged with this archive tag will get moved over to Glacier, and you can specify the number of days to retain it in S3. So back to step functions. We now have our 3 step functions. We have the ingest process, and we added that validate metadata step. If we look at the input now, you can see we're getting in this XML file. If we look at the output from that step, you can see that that's passed the XML file and just added in those settings into the event data that's been passed through our workflow. We've got our decoupled steps, so Dynamo is a separate piece. If we go to processing, this has now become a much simpler step because it's a single encoding step. If we look at the inputs there, you can see here's the details that we've got from our XML file, and then if we look at the outputs, here is the job data that we submitted to MediaConvert. So very, very flexible new service. If we take a quick look at that MediaConvert, under our account, you'll see here's my custom API endpoint specific to this region. And then if I look under jobs, here is that job that I submitted via the API. Here are the outputs, and we can actually view the JSON that I sent through via Lambda. Again, MediaConvert does its job. It creates our outputs, and then we have a final step functions that runs. Sorry, wrong region. And we have our finalist publishing workflow. And again, simplified again. We get all of those outputs from MediaConvert, check that those objects in S3 are the same as the ones that we requested, creating our CloudFront URLs for our content. If we opted for Glacier, we will tag those source assets with archive so they get moved over to Glacier. And there we go. So that is version 2. And if we look at all of that together, so now we have a infrastructure where we can ingest watermark files, metadata files, and source videos. We have our error handling, and we had CloudFront to distribute that content. And with that, I will hand you back to Usman.
All right, so with respect to the future plans, quickly, we are integrating with partners, as I talked about earlier. So Vonera is one of the partners we're working with respect to the watermarking and Verimetrics for DRM, and also Signiant for the ingest of the content. So that's currently in the roadmap. There's a lot other partners that we are working with, specifically Elemental works nicely out of the box with many of the DRM providers out there. Good, please check it out, the AWS Answers page, as Tom gave you the nice demo there. You can simply just go there and launch the template and kind of start playing with it. With that, thank you very much. We have a couple of minutes here, so happy to take any last-minute questions that people might have. And we'll appreciate any feedback that you can enter through the app. Thank you.